So we're going to start some pedigrees today, and I have a practice packet here with you. We call it the Lopez family packet, of course, because it says Lopez family. All right, I'm going to guide you through the first page, and then you're going to turn this over, and you're going to attack pages 2 and 3 on your own. Okay, so I'm going to get you through the basics, and then I'm going to set you free. Okay, so let's begin with the basics. First of all, you'll notice that you see a bunch of shapes here. You see circles and squares and some lines. Okay, let's just start by what does the pedigree give us? Okay, here there are two individuals. Okay, they're connected by a line. That means that they are related by marriage, and the line down means that they have produced offspring. This whole line here and every individual connected to that are the offspring. Okay, so you notice that some of these shapes are shaded, some are not. So if you look down right here, it says key shading equals blue eyes, no shading equals brown eyes. So this means we're going to follow this trait of blue eyes through this family and try to figure out what these individuals' genotypes are for this trait. Okay, so we start by, let's just look at number 1. What is this diagram called? It's called a pedigree. A pedigree. P-E-D-I-G-R-E-E. Pedigree. Okay. Number 2, what do the circles represent? Well, the circles represent females. So every circle in this pedigree is a female. So then that means squares, right? They are males. If you can't remember that easily, just remember Charlie Brown is a boy, and they always call him a blockhead. So boys are blockheads, boys are blocks, boys are squares. Okay, now, number 3. How many children did Mr. and Mrs. Lopez have? Well, Mr. and Mrs. Lopez are here on top of the entire pedigree. So if you count the number of individuals connected to this line that comes directly from their marriage, they had 1, 2, 3, 4 children. Okay, so how many children do they have? 4. Now, how many of the Lopez children were male? Okay, is this one of the Lopez children? No, it's not connected to that line. This is the spouse of one of the Lopez children. Okay, so look at the Lopez children, and we're counting how many of them were male. So we're counting the squares. Here's 1. Here's 2. That's not 1. That's not 1 either. So we got 2 boys. Okay, everyone connected to this line is a direct sibling from Mr. and Mrs. Lopez. Okay, was the oldest Lopez child a boy or a girl? Now, for a long time, I heard one way of doing pedigrees that said the child in the middle was the oldest. However, I recently discovered through the University of Iowa that actually, to do a pedigree correctly, you start the oldest sibling on the left, and to the right, the siblings get younger. So the oldest sibling here is on the left, and that's a girl. So, was the oldest Lopez child a boy or a girl? Girl. All right, number 6. What color are Mrs. Lopez's eyes? Okay, well, this circle is Mrs. Lopez. These are her and Mr. Lopez's children. So she has a shape that is shaded in. Down here it tells you the shade equals what color eyes? Blue. So you write that down here. What color are Mrs. Lopez's eyes? They are blue. Fine. Okay. How many of the Lopez children have blue eyes? Okay. So we are on number 7. So Mrs. Lopez, Mr. Lopez, here are their children right here connected to this line. Just count how many connected lines have shaded shapes. 1, that's not shaded. 2, and that one's not shaded. So 2 of their kids have blue eyes. Okay, now let's scroll down just a skosh so I can see what else is next. Okay, how many generations of the Lopez family are shown on the diagram? Okay, so what is a generation? A generation is a row across or a level, and then you're going to have levels underneath those. So Mr. and Mrs. Lopez represent one generation, the oldest generation on this pedigree. And then these connected individuals, they are their children, so that's the second generation on the screen, on the pedigree. And if any of the Lopez children have children of their own, here, here, and over here, well then, that's the third generation of Lopez members in the family on this pedigree. So 1, 2, 3. There's 3 generations on the pedigree. What color eyes does the granddaughter of Mr. and Mrs. Lopez have? Mr. and Mrs. Lopez, so this is question 9. This is Mr. and Mrs. Lopez. These are their children and their children's spouses, if they have any. These down here are the Lopez grandchildren. And there's one shaded in, okay, over here, but that's a boy. So what we're trying to do is we're trying to figure out what color eyes does the grandchild who is a girl, so the granddaughter, have. Well, if it's not shaded in, okay, then she has brown eyes. No shading brown, shading blue. So number 9 is brown eyes. Now we get to 10. This is going to take a while, so this is where you really need to key in. Write in the genotypes for all of the individuals on this diagram. Okay, this is where it's going to take a bit of time. Okay, so that's okay, you have it. So listen up. What I can tell you right now is blue eyes, we're going to use, blue eyes are recessive. So we're going to use homozygous recessive Bs represent blue eyes. So every shaded shape, those shapes get homozygous recessive Bs. Okay? So you can do that. That's easy. Okay? So you can go ahead and do that now. Now, while you're doing that, I'm going to write something else on here. Okay? Now, since you only had to write down homozygous recessive Bs 5 times, you should be done now. Now, if the individual is heterozygous or homozygous dominant, they're going to have brown eyes. But the problem here is some of these shapes in here are going to be heterozygous. They're not all going to be homozygous dominant. So except for the homozygous recessive alleles being written on those shaded shapes, we don't yet know what the genotypes of the non-shaded shapes are. Because all we know is that they're not blue. So that means they could be homozygous dominant or they could be heterozygous. We're going to have to do some investigating and some digging to be able to discover what their genotypes are. Okay? So this is what we're going to do. You're going to get some practice running some crosses. Okay? So here's what we'll do. First thing is, we know that Mrs. Lopez has blue eyes. So we know her genotype. Okay? You're going to write yourself a cross. Okay? Draw yourself a cross for Mr. and Mrs. Lopez right here. Okay? Right over here, draw yourself a cross. Okay? We know Mrs. Lopez. She is homozygous recessive. Okay? So we can put her up here. Now, we don't know Mr. Lopez's genotype. We only know his phenotype, brown eyes. So we're going to have to look at their children. How did they come out? We have 4 children. 1, 2, 3, 4. 2 of them with blue eyes. 2 of them with brown eyes. Okay? 2 of them with blue eyes. 2 of them with brown eyes. What can we cross with a homozygous recessive that will give us at least 50% chance of having homozygous recessive as the outcome? Okay? what's, where's this going? How are we going to be able to get that? Okay. Well, actually, I think I just wrote that in the wrong spot. Watch this. Probably here, actually. There. We'll do that. I think this makes more sense. So, what can we cross with homozygous recessive that'll give us 50% chance of having blue eyes? Because look at their kids. 50% of them have blue eyes, 50% have brown. What can we cross with this genotype to give us at least 50% brown, 50% blue? Well, if you know your Punnett squares, and you do, okay, this letter up here would definitely be recessive, okay? But if we put a recessive here, then that means all of the children would have blue eyes. Do all of the kids have blue eyes? No. So the only allele that could be written right here is a capital or a dominant letter. And now you just finish your cross. Okay? Sorry for my mistake. That's okay. If we don't make mistakes, we don't learn. So then, in order for the genotypes of the children to have made sense, Mrs. Lopez is homozygous recessive. Mr. Lopez has to be heterozygous. So, on top of Mrs. Lopez's circle, you've already put lowercase b, lowercase b. On top of Mr. Lopez, please write in heterozygous B's. Now, something that we do for the heterozygous, if this square right here is Mr. Lopez, so we have written in, we've written in Mr. Lopez's genotype. For heterozygous genotypes, you have to do something to the shape. You actually have to draw a slash through the shape, just like that. Now, if someone's genotype is homozygous dominant, we don't do anything to the shape at all. We leave it unshaded. So, homozygous recessive, shaded in. Heterozygous gets a slash, and homozygous dominant gets nothing at all. So, we have Mrs. Lopez, homozygous recessive. You should have written that here. We have Mr. Lopez, heterozygous with a slash. Okay, so cool. So now we go to their kids. The oldest is blue, so you should have written homozygous recessive B's here. This child is not one of these. This child, this daughter, is heterozygous because we have now the cross for Mr. and Mrs. Lopez. So we know this child is homozygous recessive, write little b's. This child is heterozygous, so give this one a heterozygous genotype, and then draw a slash through that shape. Slashes mean heterozygous. This one you've already written, lowercase b, right, homozygous recessive. And this child is heterozygous. There's the other heterozygous. So write heterozygous b's right here and slash through that shape. So right now, you should have Mr. and Mrs. Lopez. You should have their genotypes, and you should have all of them with the correct markings, whether they're shaded or whether they are slashed. Okay? Now, we're going to need another part to this video to explain the spouses of the Lopez children, and then the grandchildren. How are we going to figure them out when this individual, and this individual are not connected to the Lopez family bloodline? We're going to have to do some deductive reasoning here as well to figure out the spouses and to figure out the kids. The kids of the kids. So in other words, the grandkids. Okay, so hang on for part 2.